Right then, you're here, presumably because you've also noticed the relentless churn of information and, like us, prefer to extract the genuinely interesting bits without, having to wade through the digital swamp.
Exactly. Cut through the noise.
Precisely. Today's excavation focuses on OpenAI's GPT-4o, which arrived last May with a certain fanfare. We've got our trusty Eingefichter text as our guide, and our aim is simple: to understand why this particular iteration of the AI is being touted as more than just your standard upgrade.
hmm
The key, we're told, lies in something they're calling native omnimodality.
Yes, native omnimodality. It sounds rather grand, doesn't it? But beneath the marketing gloss, there's a significant architectural shift.
Yeah.
See, previous large language models, even the rather capable GPT-4 Turbo, often operated by, well, chaining together specialized components.
Like different tools for different jobs.
Pretty much. Imagine it as a series of different tools, each handling a specific task: speech recognition here, image analysis there, text generation somewhere else, with the results being passed along. GPT-4o, however, was designed from the outset to process and generate across text, audio, and image within a single neural network.
Okay, a single network.
Yeah, this native integration is the crucial distinction. Think of it less as a team of specialists and more as a single, remarkably versatile entity.
Right.
This fundamental shift isn't just about handling more data types. It allows for a richer, more holistic understanding where the AI can learn the subtle connections between modalities in a way that, well, piecemeal systems simply couldn't achieve.
So it's seeing the whole picture at once, kind of.
Exactly. Think of it as moving from understanding individual words and pictures to understanding the story they tell together.
A single, versatile entity. Almost like they're aiming for that science fiction trope of a truly integrated AI. Let's look at the practical upshot of this, starting with audio. It's not just about turning spoken words into text anymore, is it? What's the real leap here?
Well, the advancement in real-time speech understanding is quite striking. We're talking about a reduction in latency to near human reaction times.
Wow, human reaction time.
Yeah. Consider the implications for truly natural voice interfaces. What possibilities does this open up for you listening in? Beyond mere transcription, GPT-4o can reportedly detect nuances in tone, even the emotional inflection in your voice, and respond accordingly.
So it can tell if you're happy or annoyed.
Apparently so. And it can apparently interpret things like singing and ambient sounds, and AI analyzing the emotional content of a hummed melody. It's rather intriguing, wouldn't you say?
Intriguing, and perhaps a little unsettling for some.
Possibly. It hints at a much more sophisticated level of auditory processing, though.
Okay. Let's shift our focus then to how it perceives the visual world. How has its ability to see and understand images evolved?
Substantially. GPT-4o can now process and interpret visual information, whether from a camera feed or a shared screen, with greater speed and a deeper understanding of context.
So better than just recognizing a cat in a photo.
Oh, definitely. It can identify objects, extract and comprehend text within images, and analyze complex visual data like charts and diagrams. Consider the sheer efficiency this offers. Imagine being able to instantly grasp the key takeaways from a complicated infographic simply by pointing your phone at it.
Right. That could be genuinely useful.
For someone dealing with visual data regularly, this could be a genuine productivity unlock. Building on this incredible advancement in how AI understands and responds to our voices, let's now turn our attention to its perception of the visual world.
No more deciphering blurry screenshots then. And of course, the foundation of these models remains text. Where does GPT-4o stand in terms of its textual capabilities? Still top tier.
Yeah, as its core text-based abilities, reasoning, coding, knowledge retrieval, GPT-4o matches or slightly surpasses the performance of GPT-4 Turbo. And it often achieves this with greater speed and efficiency.
Faster is always good.
Indeed. Furthermore, it demonstrates improved proficiency in a wider range of languages beyond English, which is a significant step towards broader global applicability.
Faster, more efficient, and more linguistically agile. The Eingefichter text also emphasizes increased accessibility. This seems like a deliberate strategic move on OpenAI's part, doesn't it?
Oh, absolutely. Making GPT-4o available within the free tier of ChatGPT, albeit with usage limitations, is a notable step towards democratizing access to this level of advanced AI.
So more people can actually try it out.
Exactly. Previously, capabilities of this nature were largely confined to subscription-based models. This broader availability allows a wider range of users to experience its power firsthand. The simultaneous launch of dedicated desktop applications for macOS and later Windows further streamlines its integration into everyday workflows, making it even more readily accessible.
Okay, makes sense. Now, the name itself warrants a moment of consideration. GPT-4o, the O stands out. Why not a more conventional GPT 4.5? There seems to be a deliberate message embedded in that choice.
You're right. The O, quite clearly alluding to Omni, is the linchpin. OpenAI wanted to underscore this fundamental shift toward native multimodality.
So really hammer home the Omni part.
Precisely. It represents a qualitative change in the underlying architecture, not merely a quantitative improvement in performance on existing tasks. Naming it GPT 4.5 might have suggested a more incremental update, perhaps focused solely on text or code enhancements.
Right, like just a speed bump.
Exactly. In a competitive market, a distinctive name like GPT-4o helps differentiate it from competitors such as Google's Gemini and Anthropic's Claude, signaling a unique and comprehensive approach to integrated AI.
And the timing. Right before Google I.O.
Well, the timing of the announcement, preceding Google's I.O. conference, also suggests a strategic move to highlight their advancements in multimodal interaction and accessibility, potentially preempting some of their competitors' narrative. Bit of market positioning, you know.
So it's not just about better scores on benchmarks. It's about a fundamentally different way these models are designed to operate and interact with the world. Speaking of benchmarks, how does GPT-4o actually measure up against the current competition as of, say, early 2025? It's a constantly shifting landscape, isn't it?
It is indeed. Objectively quantifying the quality of these models is a complex undertaking, as it largely depends on the specific application in question.
Sure, depends what you're using it for.
Exactly. However, we can consider general trends and comparative evaluations. When compared to its predecessors, GPT-4 and GPT-4 Turbo, GPT-4 generally performs at a comparable level or exhibits slight improvements in traditional text-based tasks. But its primary advantages lie in its increased speed.
Which we mentioned.
It's a more cost-effective API access, its enhanced multilingual capabilities, and of course, its integrated multimodality, particularly that low-latency voice interaction. That's where it really shines compared to Turbo.
Okay. And when we pit it against the other major players like Google's Gemini and Anthropic's Claude, how does it stack up?
Against Google's Gemini, particularly the more advanced versions, it's a closely contested field. Public benchmark rankings, like the LMS Choose Chatbot Arena, which aggregates human preferences, often place GPT-4o at or near the top, frequently on par with Gemini Advanced.
So neck and neck, basically.
Pretty much. Gemini 1.5 Pro does offer a significantly larger context window, which is a distinct advantage for processing very extensive amounts of information, like long documents or videos.
Ah, right, the context window size.
Yeah. In terms of multimodal capabilities, both are leading contenders. GPT-4o initially stood out for its remarkably responsive voice interaction, whereas Gemini benefits from its deep integration within the Google ecosystem and demonstrates impressive abilities in analyzing complex video and audio content.
So different strengths.
Different strengths, exactly. Ultimately, the superior model often depends on the specific use case, real-time conversational interaction, versus in-depth analysis of multimedia content. Some users also report subtle differences in their personalities when tackling creative or analytical tasks,
Interesting. And what about Anthropic's Claude 3, particularly Opus, which was previously recognized for its strength in handling complex textual data? Has 4o caught up?
Claude 3 Opus was indeed considered a leading model for handling intricate text, lengthy documents, and nuanced reasoning. However, GPT-4o appears to have narrowed that gap, often achieving comparable or even higher rankings in recent evaluations, like on that chatbot arena.
So 4o is really competitive there now, too.
It seems so. Claude still maintains its strengths in processing very long documents with coherence, and is often perceived as having a more cautious and ethically aligned output.
The constitutional AI aspect.
Right. However, GPT-4o counters with its faster processing speeds and, crucially, its integrated multimodality, which Claude doesn't yet offer in the same unified manner. So while Claude excels with extensive textual data and a certain degree of ethical conservatism, GPT-4o distinguishes itself through its speed and its ability to seamlessly integrate different forms of communication.
Okay, that makes sense. This brings us to the core of its novelty, the technical architecture underpinning this native omnimodality. The Eingefügter text touches on this, but can we delve a bit deeper into the mechanics? This concept of a single neural network trained across these diverse modalities sounds like a fundamental shift in approach.
It is a significant departure from previous architectures. The assertion of native omnimodality rests on this core design principle, a singular, extensive neural network trained end-to-end on text, audio, and visual data.
End to end, meaning all at once.
Yes, trained together rather than separately. This stands in stark contrast to the earlier method of linking together separate, specialized models that were often trained independently and subsequently fine-tuned for sequential operation. Now, the critical question, the one that invites scrutiny, is to what extent this represents genuine understanding across modalities, as opposed to an extraordinarily sophisticated form of pattern recognition.
Right, the age-old question with AI, understanding versus mimicry.
Exactly. Are we observing a true semantic fusion of information, or simply a highly advanced system of correlation? What's your perspective on this, listener? Do you believe these models truly comprehend the intricate interplay between a spoken word and a corresponding image in a manner analogous to human cognition?
A profound question indeed. But regardless of the depth of understanding, the implications of this end-to-end training across modalities are potentially vast, aren't they?
Absolutely. One of the key potential advantages lies in the emergence of novel, unforeseen capabilities. By training the model on the intricate relationships between different data types concurrently, we might witness the development of more nuanced and integrated forms of intelligence that wouldn't necessarily arise from merely combining the outputs of disparate models.
Like abilities they didn't specifically train for.
Potentially, yes. Emergent properties. Consider the potential for a more profound grasp of context when the model can inherently link a spoken description to a visual scene without relying on intermediate translation steps. It's a more holistic approach.
It sounds like an incredibly resource-intensive undertaking, though. What kind of data and computational power would be required to train such a massive multimodal model? We're talking huge amounts.
Oh, the scale is almost difficult to fathom. Training a model of this magnitude necessitates colossal data sets encompassing text, audio, and images, all meticulously curated and likely annotated.
Massive data sets, right?
And the computational resources involved are equally immense, requiring vast processing power and energy consumption. These are not trivial endeavors. There are also likely inherent trade-offs involved.
Trade-offs? Like what?
Well, achieving this level of integration and broad capability might necessitate compromises in model size, which could potentially impact speed or efficiency in certain specific tasks. Although, interestingly, OpenAI claims the opposite with GPT-4o, suggesting it's faster and cheaper than Turbo.
Which is curious, yeah. How do they manage that?
That leads us to the next point. And speaking of speed, the reported improvements, particularly in audio processing, are quite remarkable. How might they have achieved such a significant reduction in latency?
Good question. Any ideas?
Several factors likely contribute. Architectural optimizations within the neural network itself, perhaps a more streamlined method for processing sequential data like audio.
Smarter algorithms.
Possibly. Advancements in the underlying hardware infrastructure, the specialized processors and memory systems used to operate these models, undoubtedly play a crucial role. Think better chips, faster connections.
Hardware improvements.
It's also plausible that they've developed more efficient techniques for encoding and decoding audio information within the model. Achieving near real-time voice interaction is a substantial technical achievement, suggesting significant advancements across multiple facets of the system, software, hardware, the whole stack.
So, to bring our deep dive to a close, GPT-4o represents a notable advancement, primarily due to its native omnimodality. It offers faster processing, more cost-effective access via its API, and greater accessibility through its inclusion in the free ChatGPT tier. All while boasting impressive multimodal capabilities, particularly in that almost instantaneous voice interaction. It clearly positions itself at the forefront of available AI models, competing closely with formidable contenders like Gemini and Claude.
Precisely. It serves as a compelling illustration of the rapid pace of innovation within this field. And it underscores the increasing significance of not just raw computational power, but also the intelligent and seamless integration of diverse forms of communication.
Right. It's not just about being smart, but about being usable and integrated. And on that note, a final consideration for you, our listener. Given the swift progress we are witnessing in multimodal AI like GPT-4o, how do you envision this technology fundamentally altering the ways in which humans interact with computers and access information in the foreseeable future?
Yeah, what changes?
It's a question worth contemplating as we continue to navigate this rapidly evolving landscape.
Indeed, food for thought.
Thank you very much for listening. If you found this exploration insightful, please consider leaving a like and subscribing. Until our next deep dive.